Hello, welcome back to Physics 1107 lab videos. Today we're going to do a lab about inelastic collisions. This opens up a whole new kettle of fish called the collision box. A lot of physics is about things colliding, and it's kind of a way to look at how things are put together. Unfortunately, collisions are interactions between two objects that happen very, very quickly and involve enormous forces. Usually they're much too quick to actually see what's going on during the collision, and so we have to use something else to try and figure out what's happening. What we can do is measure physical quantities before the collision and measure them again afterwards, and by comparing those two, try to figure something out about the collision. What we're going to be doing today is a very simple collision. This is going to be an inelastic collision of two carts in one dimension. We'll be using a lot of the same equipment as last week, and we will use it to stage a collision and see what happens. So let's go through the physics first and see what we expect. Now, to analyze a collision, we need to introduce a whole new physical object called the momentum. And momentum in physics terms is usually known as P. I don't know why it's called P. And it's given by the formula mass times velocity. So the momentum of something is just m times v. And the useful thing about momentum is that if we have two objects colliding, you can actually prove that the sum of the momentums before, P1 before plus P2 before, equals the sum of the momentums afterwards. And as long as the collision is something that happens really quickly, this basically has to be true. What we'll be doing today is checking this and see if it really is. Okay, so that's the whole idea. Let's get to the experiment. Okay, time to do the experiment. Now, this experiment, we're going to be using our blue carts and ramp again, same as last time. So what we have to have is two carts to collide. You should have two carts in your box. I put an A on one cart and a B on the other. And I have also taken some of the Velcro squares and I put two of one variety on cart A, and cart B has two of the opposite type. Here's cart B. It has the opposite type on its end. It really doesn't matter which goes on which cart. You just have to arrange them so they'll stick together when they hit. I also have put a piece of tape with a big X on it on our glass board. This is because today we're going to measure the velocity not by having it knock over echo clips. We're just going to measure the time it takes between the clang when the two carts collide down to when it hits the end of the board. And we use that to get the velocity. We will be weighting the carts a little bit to just give them a little more oomph. I'm going to put 5 washers in each cart, and I want you to try varying that when you get to doing multiple tries of this thing. So we need to weigh everything, find out how much mass we have in each cart. We need to measure the height that cart A will be going down through, and we need to measure the distance between the X and the end of the frame. And to do that, we can use the Newtonometer again. Hook on 5 washers here. There we go. 5 washers comes out to be about 35 grams. That's the same as it did last time. So let's put that down. I'm going to say that the mass of cart A is 35 grams in washers, plus however many grams there are in the cart. Hang that on there. Cart A is about 66 grams today. So it's 35 plus 66 grams. Cart B will be something quite similar, but let's just be thorough about this. Here's the washers for cart B. $35 grams worth of washers. That's the same. That's good. And cart B has a different kind of Velcro on it, so it might be a little different. And it's also about 66 grams. So these two carts have the same mass. That's good. 35G plus 66G. All right, we need to know the difference in height that cart A will be going down through, so we have to measure that. So we're going from 3 inches on one end to the height of the glass is about 1.5 inches. So the change in height is 1 inch. Height before is 3 inches. Height after is 1.5 inches. We've got those two. The other thing we need to measure is the distance between the X here and the end of the frame, because that's what we're going to be measuring the time lapse for this time. And I get 8 7/8 inches. So I get the distance, let's call that D, is 8 7/8 inches, and that's equal to 8.875 inches. Okay, I think that's all we need to measure at this point. The next thing to do is put this experiment together and actually make it happen. To get this lined up right, I'm going to put cart B so that the end of cart B is right over the X. That way when it rolls across and it hits the far end, it hits the frame, I will be traveling just this distance from the X to the frame. And don't line it up this way, don't line it up that way. Put it so the first end to hit the frame is right over the X. And you have to line this up very carefully. And a few trial runs are probably a good idea. Okay, I've got A way up here. And it looks like it's aimed at B. You want these two carts to collide and stick together. So the idea is it rolls down the hill, speeds up, Velcro hits Velcro, it collides and sticks together. Okay, we've got Audacity rolling, where you've got everything lined up, everything's measured. Let's see if I got this thing lined up right. And give it a little shove. It's down the hill, they stick together, and they hit the frame. Huzzah! Notice they didn't quite line up correctly, but they stuck together. That's the important part. And Audacity did catch some clicks and bangs when that happened. So Let's go have a look at the Audacity file and see what we can dig out of that. What we're going to try and get to by the end of this is comparing the momentum before the collision with just one card to the momentum after the collision when the two cards have hit, they've stuck together. Since they're stuck together, that means they're moving at the same velocity. And we can compute the mass, the momentum of both cards moving together. To measure the velocity beforehand, what we're going to do is use the fact that card A has rolled down a hill. Last week we found out how fast it is rolling at the bottom of the hill when we do that. To measure the momentum of the two cards together, we have their masses. We measured those already. We will measure their velocities by figuring out how fast they go from the X on the glass to the end of the frame. So we have a lot of things we're going to have to try and measure here, and we have to be very, very careful to keep everything straight. Let's start out by measuring the time to go from the X to the end of the frame. That time is measured with the Audacity file, and I've picked out the region that we're interested in. If I just play it back, it sounds like this. So I've got a kind of a longish click as they're colliding, then I've got a rumble as they're rolling along the glass, and then I've got a couple of bangs as one sets of wheels and the next roll over the edge of the frame. And the traces are pretty clear. It's pretty clean on this thing. So let's measure out the time. This, I believe, is when the collision starts, 33.505 seconds. If I look at the time when the first set of wheels rolled off the glass, that's here, and Audacity tells me the time for that, 34.171 seconds. And again, the numbers you get may be very different. The interesting part is the difference between these two numbers. All right, let's just do some calculations and see what we're looking for here. What we have is cart A starts off up the hill. So it starts out with potential energy, PE of cart A, before is mgh. And this gets converted into KE as it rolls down the hill. 1/2 mv, well, we'll call it v0, I guess, squared. We want to find out how fast it's moving before it hits the other cart. So the m's drop out, and I get v0 equals the square root of 2gh. That's the velocity of cart A before it hits the cart B. And I will use that in my analysis because I know what h is, I know what g is, I hope I know what 2 is, and with all that together I can figure out what the velocity of cart A is before it hits the other one. That will let me calculate the momentum of cart A before the collision. Using this time and this distance, I can figure out the velocity of both cards after the collision and use that to figure out the momentum after the collision. So that's the strategy we're going for. Let's have a look at the spreadsheet and see how it all works out. The first thing I have is a cell for the mass of cart A. Cart A is 35 plus 66. That's 101 grams. we want it in kilograms, so it's 0.101 kilograms. I need another cell for the mass of cart B, also in kilograms. And for the setup we used, it's the same, so it's also 0.101 kilograms. When you're doing this, you should try some runs with different masses. So I made 2 cells for that. We also need to know what's the velocity beforehand. So the velocity of cart A before, which we just figured out, is from this formula. And to figure out what this is, I need to have h, and I need it in meters. So I'm going to put in a cell for h in inches, which I measured. That's the difference of these two. So it goes from 3 inches above the tabletop to 1.5 inches. That's a drop of 1.5 inches. And we'll have another cell for that same h in meters, which I can get from a formula. That's just what it is in inches times the conversion factor, which is 0.0254. And I happen to know that one, so there we go. That's the difference in height in meters. Once we have that, we can use this formula to figure out what is the velocity of cart A before the collision. So I'll call that VA before. And that, we didn't measure it, but it should be good from the calculation. So we'll just use that. That's equals, and I need a square root of 2 times 9.8 times the height difference in meters, which is that cell. So we get that. And we see the velocity of A beforehand should be, according to this, about 0.86 meters per second. That's fairly reasonable. All right, once we have that, we can now find the momentum beforehand. So that's PA before, and that is equal to the mass of A in kilograms, which is here, times the velocity of A beforehand, which is there. And there we have that. Okay, so that's the 0.087 is the momentum before the collision. Now let's figure out what the momentum is after the collision and see if we get the same number. After the collision, the two carts are stuck together. They are both moving at the same speed because they're stuck together. They're moving at the same speed. So we have the mass afterwards, and that is the sum of the two masses before. Let's just put that in as that, plus mass of A plus mass of B. They're the same, but you may do some runs with them different. Okay, now we need the velocity afterwards. To get that, we need the difference between these two times, and I'll put that in. I'll say T collision is 33.505 that I got from Audacity, and T frame, which I got from Audacity, is 34.171. Okay, and if we subtract those two, we get the time that the two carts were rolling along together. And so So we'll make another cell for that. And that's just T frame minus T collision. There's that. Well, if we take the distance they went, which is this, and divide by the time, then we'll get their velocity together. The distance they went was 8.875 inches. So I'll put in distance in inches. Convert that to meters, distance in meters, by multiplying it times 0.0254. You see they went 0.22 meters. And finally, we can find out what is the velocity of both carts together. This is given by the distance they traveled divided by the time it took to travel that. And the velocity of both turns out to be 0.338 meters per second. Finally, I can figure out what the momentum is afterwards if I take the sum of their masses, the mass afterwards, and multiply it times their velocity afterwards. And we get that. And we see that the momentum before, when there was just one cart, the momentum of A by itself, was 0.087 meters per second. The momentum afterwards, with two carts stuck together, is 0.068. So we lost some momentum in there someplace, but they're certainly close. And that's pretty good for an experiment like this. Once again, what I want you to do next is to do this experiment at least 3 times with different combinations of masses in the two carts and different heights. And run them through the same spreadsheet and send me the results.